you how to make this airplane project. I'll just quickly play it to show you how it works. But basically you've got this plane and you can fly around with WASD for pitch and roll controls. I'll just be showing you how to make this airplane part. I'm not gonna worry about any graphics or anything like that. But if I take a look here, these wings are just a graphical representation of what's actually going on. So I'll just disable everything else. This is basically the plane without any of the other stuff. The blue cube is the center of mass. And I just like coding it this way because it's easier to visualize. So you can see each of the wings moving, as well as yaw. And so you've got full control surfaces. You can customize the degrees of how much pitch and how much roll. And I've got the speed up here. I won't show you how to make this because it's pretty simple. And yeah, so in the plane object, you'll be able to open up the wings, and here you can see for roll it goes 8 degrees, for pitch it goes 30 degrees, and for yaw it goes 45 degrees. You can fully customize all of these, and for each of the wheels as well you can fully customize all of this. So now let's take a look at how to actually make this in a new project. So let's create a new project. We'll just use the 3D built-in render pipeline, call it airplane tutorial or whatever you want to name it, and that should be good. So we'll create the project and we'll load in. Okay, now that you're in, I'll just start off by creating um, a few things. So I'll create a cube. This will just be our floor. Reset the transform and set the scale on the X and Z to like 100, so we've got this big surface. Next, I'm just going to create our actual plane object. So I'm just going to call this plane. Again, reset the transform. I'll move our ground. I'll just rename this to ground, and I'll move the Y to -2 just so it's below it and so that we can see our object here. So make sure you've got a box collider, add a rigid body, just keep all the values at default. And now we're just going to add a few graphics, create a 3D object cube. This is not going to be functional, this is just going to be purely so that we can see what's going on. But I like to make the Z something like 8, and then make these like 0.3 and 0.3, and I'll move it backwards on the Z. So the plane in the forward direction is going to be going this way. So this is just so we can visualize what's going on. I'm also just going to make the wings right now. So again, in this cube, make sure you delete the box colliders. So any of these sub objects that are just for graphics, delete the box collider, or else you're going to run into issues. Now I'm going to just copy the cube, and I'm just going to name this wing, and just change these so that it looks decent. So I'll just make these two, move it over here. This is just going to be the back for pitch. Copy that and change the X to negative. And I'll just make another, and this will be for roll, and we'll make the X a bit longer. So this is just what our plane looks like for now. I'm going to copy it, make the X negative, and you can copy by pressing Command C, Command V. That just copies it. So yeah, this is what we have for now. You know what, I'll quickly just add the yaw. So we'll make this, Actually, for yaw, it was a bit more complicated. You have to... Okay, I'll start over. Select this wing, copy it, and then on the X, not on the X, on the Z, put 90 degrees, and then align it here. You can just set the X to 0 and move the Z up, or the Y up. So that's going to be your yaw. Alright, now, going into the plane object, right here, we're going to add a component, and we're going to just call this plane, new script, create an add, and let's double click it to open it up in VS Code. So I'm not actually going to code the whole thing right now, I'm just going to paste it in and then explain what it does. I think that's much quicker. So this is the plane script. You can find it in the GitHub link below. So I'm gonna delete a few of the things because we don't need everything for the demo that I just showed you earlier. Okay, and before we get into this, I actually want to add one more thing. So I made this wing class. So in your assets folder, create a new script and just call this wing. Double click it to open it up, and this is all the code you need in the wing script. So basically we're gonna store a vector 3 degrees of motion roll pitch yaw. So the vector 3 x value is going to be the roll in degrees, and then the y value is going to be the pitch, and then the z value is going to be the yaw. That's basically how I organize this. Then we're going to have a public game object, which is the actual wing object. So we're going to drag in this wing object so that it controls it and makes it look proper. And then we have hide in inspector because I don't want this to be modified, but we're going to have a vector 3 for default local Euler angles. This is basically just so that we can, when you're not pressing any controls, it returns back to the default angles. So that's basically it. We are also going to quickly make another script and just call this wheel with a capital W. Double click it to open it up. And in this, it's again a really simple script. Just basically store the game object of the wheel. This is the location of the object. You'll see what it's used for in a bit. The height is just how high you want the ride height. So like how high should the suspension be. Then we've got a float for wheel size, and then we've got a float for last distance. This last distance is not going to be modified in the inspector as it says here. It's just used for damping and other things for the suspension. Alright, so now going back into the plane script, a few of these errors are gone. So we're going to store a list of wings and a list of wheels. We're also going to have this rigid body. We're going to have a vector 3 for input, which I'll show you how to do in a second. We're not going to be using the new control system. And we have vector 3 assist input. All of these are going to make sense once you read through the code, but then these are pretty self-explanatory. We've got throttle, wing strength, jet power. Bool assist, this is just, I've got a little bit of assist to basically smoothen out the controls and not make it spin uncontrollably, so that's all this does. And then we've got a bool for braking. Yeah, this is just to stop the wheels or slow down. I don't think this is actually used yet, but it's something you can implement in the future. So this I'll just comment out. Okay, so now getting into the actual code, I'll also delete this particle system. I'll keep it in, but basically you can use this particle system to play or stop playing the jet throttle on the back. So if you're making an actual plane like that, then you can use this particle system to do that. So in the start method, we get the rigid body, and then for each wing, we set its default local Euler angles. Then we've got this clamp vector method for vector 2's and vector 3's. Basically, it just clamps each value between -1 and 1. It's pretty simple. Now in the update method, we've got this input where if you press spacebar, the throttle is 1, otherwise the throttle is 0. And then if the throttle is above 0.5, so if you're pressing space, it'll play your particle system. Otherwise, it'll stop playing your particle system. But right now, we're not going to use that, so I'm going to comment it out. Next, we've got a float for speed reduce. This basically will reduce how sensitive roll and pitch inputs are. Depending on your speed. So if you're going really fast, you want the inputs to be less extreme, so you don't fly out of control. And basically, this is just a float value of a value between 0 and 1, and we will multiply our input vector with this to reduce the sensitivity at high speeds. Basically, this code here is it gets your angular velocity in the world space, converts it to local space, and then takes out like specific roll speed, pitch speed, and yaw speed depending on your local velocities, angular velocities, and then it puts it into a vector 3, which is clamped, and we multiply by a few constants here. And also the speed reduce value, but this just took a lot of tuning to make it feel natural and easy to fly. So this just took multiple hours of tuning. So then we've got the assist x is multiplied by speed reduce again. So basically I reduced the roll sensitivity like a lot, like speed reduce to the power of 4. Again, this is just kind of tuning stuff, but I just recommend keeping this stuff this way. Just copy the script over from the GitHub in the description and it should work. And then if we're using assists, then assisted input is going to be roll plus roll pitch speed. This roll pitch speed is basically what we're going to add to our input to use the assists. And then otherwise our assisted input is just going to be equal to input. Now in the fixed update, this is where we do all the physics. So for each wing, we're gonna basically figure out its velocity and then add the appropriate force at the position of the wing. And then this rotates the wing, this adds thrust, and then here we draw a ray so that we can see which way like the wing is facing basically. And then for each wheel, again, we're gonna send out a raycast, and then this is a damping float, and then it adds force at that position, takes in like depending on the damping, the hit distance, the wheel height, and it puts it at the wheel location object. So after that, we set the wheel last distance to hit distance. This is basically used so that then when it's run again, we can calculate the damping force. All right, now all of this set input is not needed. Just gonna delete those, and now for our input script here, for our input vector, for our input vector here in the update method, we're gonna just type input.x is equal to input.getAxis horizontal. The y is gonna be getAxis vertical, and then the z is gonna be if input.getKeyCode Q, the input.z is going to be 1, otherwise if you press E it's going to be -1, and otherwise it's going to be 0. So that's how you do the yaw. And now heading back into Unity, make sure you press Command S to save that. We shouldn't have any errors. And now here in the wings, you can add our five wings. Sorry for the voice crack. And we'll just go in here. Now this part might take a second, so bear with me, but these two, I'm just gonna rename these to back left. This is gonna be back right, and I'm gonna move it down here. This is gonna be front right, front left, and I'm just gonna call this yaw control. Doesn't really matter what you name it. It'll just make it easier here. So I'll put in front right in the game object here, front left, back left, back right, and then the yaw control. Okay, and now for the front right and front left, we want there to be roll. So I'll just put this to 20 and I'll put this to -20 because we want one to go up, one to go down. Now for pitch, we're gonna want around 30 degrees, and then for yaw, 45 degrees. All right, let's just play this real quick. And yeah, so that happens. I'm just gonna move the floor up so that we don't drop at all when we spawn in. Now let's play it. Okay, so now you can see these control surfaces work. The yaw doesn't work, but that's not too important for now. Although it is, the pitch is inverted. So if one of your controls is inverted, just go to the plane here. Since my pitch is inverted, I'll just change these 30 to -30. Alright, now it should all be working good. If I hold space, the throttle is not working properly. So now let's just disable the ground and see how this flies. Okay, so now we can see that we've got some problems. Alright, so let's come back into here and see. Alright, so I'm gonna come here. If I move this in the positive Z direction, that is what it should be. So the only thing I'm just gonna do here is remove the yaw game object. Alright, now it basically works. So I'm gonna have to do a little bit of tuning here. I'm gonna increase the jet power to something like 20. And the assists here, I'm just gonna reduce them quite a bit. So I'm just gonna multiply this by 0.2. Or actually, I'll just disable them for now, just so that we can see it's working. Yeah, so now we've got basically a fully functioning airplane. I'll move the main camera. Actually, for the main camera, we'll add a script and we'll just call this follow, create an ad. Double click it to open it up as well. And once you're in here, just put this code in. So we need a public transform for the target. We're gonna have a follow distance and a follow speed. So in the late update, we're gonna obviously constantly look at our target, and then if the distance is further than the follow distance, then we'll take a step towards the target basically. So that's how the follow script works. You can just copy that. Now if we go to play, we have to first drag the target into the target transform, and now we can press play. And we can follow our plane around. So now we've got a fully functioning plane. You gotta tune this a bit. We'll see if we can make the yaw work. Let me see here. Yeah, now the yaw also works. I'll go into the plane script and I'll enable assists so that you can see what they do. It will definitely make it quite a lot easier, especially with mouse and keyboard. Oh, here it just lags out. Okay, what I think the problem is we need a little bit of drag, something like 0.05, and you can just keep the angular drag the same. I'll make the mass a bit higher, actually we'll keep it at 1, and let's make the angular drag 1 for now, just so that it doesn't spin out of control. I think this should fix a few things. But first, actually, I wanna do something. Select all your wings and just move them forwards. I think this is gonna make it quite a bit easier. You don't want them too far past the center of mass, which is the square, but you do want them kind of evenly spaced out. I find that works the best. But generally, just like slightly moved back. So something like this should work pretty well. Let's take a look here. And yeah, I don't know why the pitch and roll is breaking, so I'll come into here. Okay, I'm just gonna change these constants from 0.4 to something like 0.1. And this should reduce the assists and stop the oscillations, so let's take a look if this works. Yeah, it mostly works. Now you can pretty comfortably fly your plane around. If you've got a graphic that you want to put on it, and you want the wings on the graphic to actually follow it, then just make them a child of the game object of these wings, and then make them invisible. So like, let's say you've got, this is your wing game object, just make it a child of it, and then disable the view on this, disable the mesh renderer, and then you've got your wing graphic here. So yeah, that's basically it. Let me know if you want me to make a part 2 in this, which shows you how to make the little bit of UI and just a few other things here. But that's basically it. Let me know if you liked the video. Leave a comment down below of what you want to see. Also, you can angle your wings slightly, like a few degrees like this, to keep it from constantly pitching down. And yeah, just good luck with your plane project. Good luck tuning it. And yeah, I'll see you in the next video. Bye.